Now I think the viewers want to see the practicals. Let's just dive in. You can actually explain while
Sure, definitely. Okay, so yeah, let's get start with the practical. So in the practical, so we are having a we took a one device that uses in the home automations, that is the smart plug of 16 ampere. So we are keeping the name as a confidential. So this device is used to work in the Wi-Fi, and then also because of this device we can have we can control anything like a fan, geyser and anything. And right now we are talking about the UART sections, so we directly jump into the UART sections. We have already initialized the device and feed the data, whatever that, and then after that now we have an directly access to the PCB. So in PCB, the first thing is that we have to recognize each and everything from the PCB itself, and also the main thing is like UART sections, right? So from that now as you can see in the PCB, it consisting of the chipset and then this capacitors and the relay, everything is there already, right? In the back side, if you can check, the button is also given. Because of that we are turning on and off of the switch automatically. And back side we have multiple test pins over there, PCB communications, they are already connected with one to other. Now we are directly jumping into the chips which we are using the UART communications. So as you can see, the chip which we can see here is a Wi-Fi module over here, which is of backend chip. So in the backend chips we are having multiples like registers is there, antenna, clock, and then SoC chip is there. So from these chips we are going to see now the UART pins, that is the RX, TX, GND, VCC. From this, the backend chips is consist of multiple chips, that is as you can see here, RX and TX pin is already visible, right? RX2 and TX2. These pins, because of that we have an interaction to directly the firmware of the chip and whatever the device is consisting. And the back side there is 3v3, GND, RX, TX, 1, and then P24, P26. These are the other pins which is consisting of by the chipsets only, back and off. And from this only the main chips are main pins are RX and TX and GND, VCC. Now we are not disassembling the chip from the device. In the device itself we will going to solder the pin, and from that we will have an engage with the UART sections, right? So now we will directly solder the chip one by one. So we'll start with in the front end also, as you can check there is a 5 pins. So in that one RST pin is there, we will solder it. Now first we will apply the flux over here, the solder flux. Okay, so from that each of them, while we are soldering the wiring, so each of them has to be at a specific point and they will be not engaged with the others. So now we are going to be solder each of the pins. We have already the chip line. So now we are going to connect with the one by one, like GND, RX, TX, and then reset pin. Okay, and in the front end also we will apply the flux, so that they are very very minute pins. As you can see, these are very small chip, okay, the pins. So we will connect them like RX and TX. So these are very complex part, so we should be very careful. So we will now have a wiring. Okay, so from that wiring, so we'll connect the these are the smaller wire. So we are connecting the RX and TX2 from here, and from the back end we will connect the GND and VCC. So from the the pins which is TX2 and RX2, we are connecting with the wiring, that is the conductive wire which we are using, the electric wire. Because of that we can transfer the data from one end to another end we have already have checked the multimeter. By multimeters we can check the data in the continuity mode, like one end to another end. So TX2 is already shouldered. Now we will shoulder the RX2 also, so that we have a communications of UART. So now we have the other part also connected, and now we are connecting the other part, that is this one is the VCC, so 3v3 voltages, and now we will connect the GND. So GND pin is used to ground the whatever the device is working on. And the last pin, that is like reset pin. Because of the reset pins, while we are tapping into the ground, the reset pin, then the boot process will start, and then we can interrupt the boot process in between to get a root shell. So this is the reset pin which we are shouldering at the another side. So the reset pin is also known as, in some devices, is CEN pin. So now we have connected with all the pins RX, TX, and other. So the extra flux will be removed, and then we will clean the pad. And now the RX and TX is very smaller pins, right? So they are very like minute and also complex. Because of that, we are connecting that pins to the other PCB so that we can have easy access. So now we have directly connected to that. Now all the things is connected. Now what we do is like get a connected connections with the UART. So we will use the TTL to USB communications. So from that we have directly interactions with the devices like software like Arduino IDE and PicoCom, Minicom, Putty, whatever devices we are using. So in this device we have already have all the communications. This is TTL to USB, that is CP2102, and now in that also we have as you can see the pins, that is GND, VCC, RX, TX for the chips. Now we are connecting the pins in the RX has to be go into the TX, and TX has to be go into the RX, GND to GND, and VCC has to be in 3v3 voltage, or as per the device need like a 5 voltage or 3v3 voltage. So after connecting, so we have a terminal over here. So in that we are using PicoCom. In PicoCom, as you can see, the command is that PicoCom -B, B means baud rate, that we are using. The first is 57600, and the port which we have connected like /dev and /tty USB 0. So in that we have connected, and then we have also connected the device into our monitor. So for that we can have an easy access like how the reset pin is working. So because of that we have a small dialog of a device also. And while running the code, so as you can see, the more details of the PicoCom is shown, like version v3.01 is using, and the rest of all the commands. Now we are going to interrupt the reset pin with the ground so that we can directly have an access to the terminal. So terminal is ready, and now we are interrupting. As you can see, the datas are very garbage and non-human readable, right? So because of this, this occurs because of the mismatch of baud rate. So now what we do is like stop the process and remove the device. Okay, and also we are again writing the code. We'll clear it first, and then again we will go for the PicoCom command. And while changing the baud rate, like we have previously, baud rate is of 57600, now we are going to use 115200. So we are like changing the baud rate, as you can have a baud rate of 9600 and any other also. Again, while we are connecting the power to the device, and also we are connected the device. Now again we are running the command, and again we will interrupt the device in between by reset. So again by interrupting, again we are getting the human readable form, right? So we have a data of a human readable form, and also the servers and every data of the boot kernel, all the data are visible. So again, now we will see what data we have occurred. Okay, so from that beginning, so in the picocom, so we have begun with the picocom command. So each of the details of the picocom is in the front, and then after that the chipset name and what are the addresses, registers, and they are all mentioned by the chips, what the devices are using. As you can see, the chip is using the Tuya, right? So Tuya is a cloud, so this is a cloud forms where the data is storing. Like we are using the one Chinese product, so this is the like firmware, the Tuya, which is storing. So these are all stored in the Chinese cloud market. So because of that, these are insecure. And also, as you can see, there are multiple datas which are here. So when the Tuya like implemented like in September, and like mostly very old versions, and these are the registers where the datas are stored, and then other things which we go for. And like we can analyze all the datas here also. And then after that, if we are going for the higher data, so we will see each and of the data. Like we have a read of the commands, and also if you can see there is a SSID mentions, right? So chip data is mentioned over there, of course, so that we can have an easy access to the chip also of EEPROM and everything. Now we will go for the datas which are like very sensitive, so we will go one by one. So here are more datas are there, we will go cover it each in detail. So now as you can see, there is like SSID. So now we are using it without like implementing datas and SSID of the routers, without connecting of that. Because of that, we can see the SSID name, which is Tuya Dev, the default test ID is given. So, and also we can see the datas which are here, and the most confidentially datas which we can see here, as a product key is visible in the clear text. And also along with the product key, there is a firmware key, and below of that, so that is main concern of the device. Because of this, the product key, firmware key, by using this all the keys, we can like decrypt the firmware, and then after that we can analyze the firmware thoroughly, and also we will reverse engineering each of the part by doing the Ghidra and everything. We have also the series coming in the days, so in also we are covering up the reverse engineering of the part of the binaries analysis. These are the all the binaries we are going to analyze, and from that we can analyze the vulnerability finding and how the Ghidra is working, reverse engineering, all the things. In that, the firmware key and everything, the confidential data is there from the UART section. These are the important things which we are getting from here to get it, and then we can analyze in the Ghidra. So these are the main confidentials. And also from the side of UART, so you can get an root shell access also. Whenever you are having a device with the root shell access or some, there are some multiple commands is there, in which section you want to go, TFTP, file transfer, or some like a CLI command. So you can have an interruptions, and then you can print your environmental variable, and you have interruptions of boot, and then after that you can have a directly access to the root shell access. Or sometimes the what vendors do is like keeping the password very strongly, or sometimes they are keeping like a default only. Because of that, easy access to the root shell access is also very harmful. So these are all the things we can do through the UART. So this is the practicals which is covering of how the boot is boot is working, and also how we can go into the keys and the datas which are running from the back side of the device. So these are all the things which we are covering to the UART. And then the next section is analyzing of the binary, dumping the binary, how we are dumping the binary from the UART section, and also how we are analyzing from firmware like binary file in the Ghidra. So we are having a series coming, so stay